Okay, we are going to do a demo on nMap, and there happens to be a GUI version called nMap, which let me show you as well, which actually makes it so easy. Runs on Windows. Pretty sure there's a Linux version for sure, and majority of the Linux distros work on Mac, so you're pretty much covered in all aspects of it. I'm running this on the forensics image that all the forensics students get. So if you're in forensics or pen testing, you have one or could have one if you want one. And if you ever want to just play with this stuff, I can create unlimited images. I have no problem giving them out as long as you all use them. It's when students don't use them that it's a pain in the butt. So, all right, so I'm going to show you, first of all, what the heck is nMap? Anyone know what it even stands for? Network Mapper, or Network Map, yeah. It helps you basically scan your network. Well, first thing I'm going to do here, actually I'll leave my resolution. Can y'all see that okay? All right. I'm inside the vSphere system, so I'm going to, y'all know how to find out what your IP address is? IP config. All right, let's do that.
Just Google what's my IP address.
No, wrong answer. Actually, he brought up a very valid point. I'm going to do exactly what he said, and we're going to see why it's...
What did he say?
I said, or Google what's my IP address.
Go to IP chicken.
Okay.
There'll be different IPs.
What's my IP address .com, I think it is, isn't it?
You gotta have another S there, which I'll take.
Nope.
What's my IP address? Okay. I just want to make sure it wasn't some crap. Okay. So wow, this one is different.
IP chicken?
Yeah, just IP chicken's so much easier.
Let's say IP chicken.
I think it's what'smyip.com.
Maybe. Try it.
I'd say I think Google now integration unless you actually have Google tell you.
There it is. What'smyip.com. 164.58.104.194. Same thing, you can get an IP chicken. Now, in this window here, I'm going to type ipconfig. And if you can see the screen, you'll see what's my IP told me it's 164.58.104.194, and ipconfig told me it's 10.10.40.123.
Internal.
Versus external.
One's internal, one's external. Okay, kind of important. You know the difference.
Especially for
Like in forensics, when I'm asking you an IP, I'm always referring to the external, unless I tell you internal. Internal is private stuff. Okay? So that's my IP address. If I want to scan my machine with nMap, what I can do is 10.10.40.123.
Is that your external?
That's my internal. Okay, 10.10.40.123. Now, hopefully, can someone mess with the zoom so y'all can see those commands a little better? You're sitting right there. I think it's that little lever on the front. That.
You have the remote right there. It's on the
Oh, actually, that's true. It is on there. But there's the manual one. That'll work.
That went hard, but
But there's that other one that's actually easier. But okay. So, you'll see what I did is I put in my IP address. Okay? Now, what this tool did, nMap is just a GUI interface for nMap. That's all it is. So you see it actually built the command for me. nmap-t4-a-v and then the IP address. Okay? So just by putting that, now I can do scan, and what it's doing is it's scanning my local machine. It's starting nMap 551, and what we're seeing here is just the results of the command. Okay? Shouldn't take that long to run. There it is. Came up with all kinds of stuff. Okay? Wow. Holy majoli. Came up with all kinds of stuff. Okay? What I normally tell students is, and up under this profile option, now see that command up there? Watch what happens when I do quick scan. Change it. You see that? Now I'm going to run it again. I'm going to, okay. You'll see it change it. Now what this will do is it's much quicker, in theory. There it is. No, it's still giving me a lot of ports. That's because I'm scanning my own. It's usually better if you scan remotely, but the state, and I'm going to show you something else you can do with state. I'm actually going to do it on this machine right here. There's a website which you should do at your house. grc.com. www.grc.com. Steve Gibson, if I remember that's his name, I think, he wrote a program called SpinRite and also Shields Up. Anyone remember SpinRite? Is anyone old enough to remember SpinRite? SpinRite was very handy back when we had RLL drives, before IDE drives, because, I mean, you had to run SpinRite on. It would literally take days, but it made your drive so much better and so much faster. But he created Shields Up. So we're going to go down here and find Shields Up. You should try this at your house. It's kind of cool. What it's doing is we just told his system to try to get into our system. So it's looking for open stuff. Okay? And let's just do common ports. Okay? So he automatically knows my IP address. And if you ever see a pop-up on your machine, there was actually a virus there for a while that said, hey, your IP address is visible. That's bad. You click here to fix it. Don't. It's kind of like your house. There's a number on the front of my house. Is that a bad thing that there's a number on the front of my house? No.
Yes.
No, it's not. Okay. So it ran it. Now I have stealth. Okay. Stealth is good. You got open, which is open, like the door's open. Closed meaning he knows there's a port or the door's there, but the door's closed. So which better? Open or closed? Closed. Stealth means we can't even tell if you have a door. So which one's better? Closed or stealth? Stealth, obviously. Okay?
First time I ever ran this on my system at home, it told me if you're seeing this pop up, your system is.
I ran it. It was funny because I taught this class. I used to teach all the network admin courses, and I talked about doing this. And one of my students called me. He's like, "I just ran that at home, and I'm not sure if it's good or not." I'm like, "What's it saying?" He goes, "Well, here's what it says. It says, hello, Daryl. You're running Windows whatever version, using Office whatever version, currently editing such and such a document." And I'm like, "Whoa, dude, you have like everything wide open?" He had NetBIOS, he had everything wide open. The application could see his user account, his machine account, his software, the open files, everything. I'm like, dude, how did you possibly leave that much stuff open? It's crazy. Now, inside of this machine, I'm going to run it. Yeah. All right, so I'm in here. Now I'm going to go same thing. It's grc.com. Maybe. There it is. Shields up. We're going to do the same exact scan on this machine. And proceed. And we're going to do the common ports exactly like I did a second ago. Okay, whoa. We failed. If you notice, the other one we passed. This one we failed. So what does this mean? Well, we have HTTPS. It's closed. So is that good or bad?
That's the encrypted version.
It's encrypted web traffic. I mean, it's closed, which is good, but it is there. So that's not as good as true stealth, but better than open. Okay? Now, if I was to scan all the ports, you would actually see a few more of them like that. What that means is Rostate has a different firewall than we do in the vSphere system. Because we want certain things to be able to get into the vSphere system so we can do certain things. If you were to scan more ports, you'd actually find quite a few open ones. Because we need some of them open. Okay? So run this at your house. If it says true stealth, you're good. That's awesome. I would actually recommend running all ports. And if you get some failed, look and see what it says. I mean, he even tells you down here what they all mean. It's pretty amazing. So I highly recommend running that. But the reason I did that was I wanted you to, see what an external scan would look like. I was actually teaching a forensics class up in Missouri. No, I was actually in Colorado teaching this class. And we're using nMap, yes.
Was the stealth for open ports or closed ports?
Stealth means we can't even see the ports. We don't even know. It's kind of like we don't even know you got a door.
Okay.
Which is the best. What it is, the Rostate firewall doesn't respond to anything. Okay, ours has that port enabled, has the port, but the port's turned off. But it can see it. It's not. See, Rostate, you can't even see the port. That's why theirs is better. But we need ours to do different things. That's why we're on a separate network. So for students, you can do more stuff. So, all right. Now I want to scan a different machine. I'm going to randomly pick a machine here. Randomly pick one I know. I'm going to do 10.10.0.10. That should be up and running. Okay. Now you see the command's the same. I'm still on quick scan. I should find it. Alright. Now you notice I didn't get nearly as many this time because it's not scanning itself. When it scans it itself, it's kind of, you can see a lot more if you know what I mean. Okay, scanning across the network, you can't see as much. But this machine here has port 22 TCP open, which in this case is SSH. We have port 80, which is HTTP, then HTTPS, and then VNC. Okay, y'all see that? Okay, I hope.
So the one you had us scan gave us all different IPs.
Right, I'm going to get to that here in just a second. Okay. While we're still on that single IP, I'm going to do an intent scan. I want you to actually, you know what, before I do that, if you look over here on the left, come on, you'll see it actually came back and gave me the name. drac1.rose.labs. Anyone know what DRAC stands for? Dell Remote Access Client. It's basically a card built into our machine that we can even reboot the machine remotely. And it uses VNC for the terminal emulation so we can see the screen. It connects on SSH and HTTP. Okay. Now if I go under services, it'll actually tell you what services, well, it said ran the other ones. That's why it's showing you so much. But here under the ports, it'll tell you the ports. It'll even tell you the network topology. Okay. The local host is me, and then there's the DRAC. Okay. Host details, it tells you a little bit about it. Actually let me scan a different IP. Let me, I think 50 should be up. I want to get one with some more details in it. Oh, I know one. Actually, this one will work. Okay, is it done? Come on. Oh, I got intent scan on. Well, heck. Cancel. Can I cancel it? Can I say stop? Okay, it stopped. Okay. I want to remove all these. Okay. I'm going to run it again, but I want to only do the quick scan. I'm going to show you the difference here. Okay. So we got the quick scan of that IP. What's my watch telling me? Okay. Alright, so it came back and it told me we got FTP, HTTP, we got MSRPC, which is Microsoft. It's a remote procedure call. 135, 137, and 139. If you ever see those ports open externally, that's a bad thing. Those are net BIOS. That's normally like file and printer sharing and naming and stuff like that. Okay, but you see we got quite a bit of stuff open. Now if I go into host details, it tells me the host is up. It has 9 ports open, 91 closed ports. We scanned 100 of them. It really doesn't tell me much else about it. Okay, now I'm going to change it to intent scan. Okay, so we really don't know the operating system. Or actually, we don't know any of that, do we? Yeah, shouldn't show us that. Shouldn't show us much else. Okay, so now I'm going to change it to intent scan. And it should tell me more. And it should actually come up, if this is the right machine, even tell me the exact name of it, or at least the type of it. Come on. We are recording, aren't we? Okay, good. Okay. Okay, now we got the name. It's file server 1. Okay. Right down here at the host name. Let's see, is it not giving me any more up there? Is it done? Okay. But intent scan does a lot more stuff, takes a lot longer, but we'll find out a lot more for you. I just don't know how long this is going to take. I don't recommend running intent scan unless we specifically tell you you need to. Because if you're scanning large networks, that could actually take quite a while. Okay? Yeah, it's still going. Come on. Should tell me some more stuff. Oh, do I? Yeah, still not showing you. Come on, show me the rest. Shouldn't take this long, you would think. I might not have picked. Well, actually, file server should be a good one to pick. Well, I don't know how long it's going to take. All right. Well, but there it goes. There it goes. If you look down here at the bottom now we know it's a Windows Server Vista SP Service Pack 0 to Service Pack 2, Server 2008, or Windows 7 Ultimate. Why is it to give me all these different choices? Anyone know? Right, because of the signature values. It's not 100% sure. Because you can actually, it's like, I mentioned TTL last time, didn't I, when we were doing the Wireshark one? TTL, time to live, depending on your system, like a Unix-based system, I'm pretty sure they start off at 64. Windows should start off at 128. So just by looking at that alone, it can determine what type of system it is, or at least get a better idea of what the system is. So it did actually come up and tell me all kinds of more information. Okay, different ports, so it's one of these. Again, it's not totally sure, but if I was trying to break into the system, now I know a lot more information about it. Okay, now I had my students tell me about these ports. Well, how do you find out what the heck these ports are? Well, I'm going to show you one way to do that. If you go on your computer to see Windows System 32 .drivers .etc. or spell it correctly. Did I spell it wrong? There it is. Okay, it came up. That's Windows System 32 drivers, etc. This is a very important folder. Okay, inside here there's a file called services. You'll see that. And if I was to open this file in TextPad, should be able to see some stuff. This tells me like port 7 is used for echo. Okay, FTP data is 20, FTP control is 21, SSH is 22. I mean, it goes through and tells you quite a bit of stuff about all these different ports. Okay, POP3 is our email, Post Office Protocol version 3, so on and so forth. Like now the higher numbers, like let's get into the 4000s here. It doesn't know a lot. If you look, there's only 4001 listed. Reason is anything over 1024 can really be used for anything. Now, let me go back up to the top here for a second. So, which port is FTP? 20 and 21. 21 is the control, and 20 is the data. In other words, 21 says, hey, I need this file, give it to me, and then it transferred it on 20. Okay, so two different ports. It's funny because when I first started working here, I ran a consulting business. Yes?
So why are so many of these listed twice? Do you know?
Because someone can work on multiple ports. Some listen on one, transmit on another.
Like, some of them are actually like everything is just completely the same across the different lines.
Like which one?
Like layer 37.
But that's a TCP and a UDP.
Yeah, right? Here it's different. It's like DNS should be 53. Yeah, see DNS? DNS is either TCP or UDP. UDP is preferred because UDP is quicker. UDP is a connection list protocol. Okay, TCP is the connection oriented protocol. So a lot of these things will try to go over UDP first, and if they can't, then they'll try TCP. Like for most of our stuff, we just block UDP. We use UDP internal. Because if you're doing external, we just think it's a little bit safer to go the other way. But okay, so back under FTP here. So when I first started working here at Rose State, I ran a consulting business for many years, and Rose State really didn't care. It's funny because when I got hired here, the dean at that point, Dean Kane, on my birthday gave me a computer game. I'm like, this is kind of freaky. She gave me a computer game. I'm like, okay, when I get home, I'll have to play this game. Oh, no, go play it on your office machine. I'm like, okay, this is even getting freakier. But they really didn't care. It's like now I do some other stuff at work as long as I get my job done, and plus I put in a ton of extra hours anyway. But when I first started doing this, I ran my consulting business, and I did a lot of remote access into different systems. And Rose State blocks a lot of ports, but they don't block FTP. So what I did was I went to the systems like RDP, remote desktop at home, 3389 for terminal services, 3389. So what I did to all my clients was I went into their system and into the registry and said, for terminal services, instead of 3389, use port 20. And then I could connect remotely from here into their system out on port 20. And it worked like a champ. And our network administrator at the time, Mitch Parsons, real super sharp guy, he didn't care what I did. He knew what I was doing, but I knew what I was doing, so I wasn't screwing anything up. He came to me one day and said, man, I was looking at the network traffic. You do a lot of FTP traffic. He says, yeah, don't I? Sometimes for hours on end. He knew exactly what I was doing. But my point of that is, just because we tell you on this file here what port is what, doesn't necessarily mean that's what the port is. Okay. Way back when I first started working for an ISP in the middle 90s, we had a provider downtown that I was working with. He was all Linux-based systems, which is great for web hosting because Linux is free. But the funny thing was, he did nothing with the defaults. Every port he remapped to a different number. Every directory name in his Linux, he recompiled his own kernel, so every directory name was different. Everything was different. His reasoning was, if you break into his machine, exactly, you don't know what the heck's going on. And it was so tough to get anything done. I was like, oh no, where's the HTTP docs? Oh yeah, well HTTP docs is really, Suzy Q or something. It's like, what? It was crazy, but it was very secure that way. Okay? So this is a good place to find the ports. Now, I tell my students I want to know what the ports are. Don't tell me RLP. Don't tell me NetBIOS. Like a 445, let's find 445. 445 is Microsoft DS. What the heck does that even mean? Anyone know? It's Microsoft Directory Service. This is actually a port used for Kerberos when communicating with a Microsoft Active Directory system. So that's kind of what I wanted my students to find out, because a lot of times you look at this, you're like, if you look at traffic, you're like, man, I see port, whatever, 445, but what the heck is it? Because sometimes these files don't tell you a lot of information. So, whole point with that was just to have them go look up some of the stuff. And sorry, Microsoft DS doesn't tell me a darn thing. Okay, it's really domain service is what it stands for. All right, so let me get out of this file here. All right, so in nMap, I showed you how to do individual machines. Now, for my students in their project, I told them to scan the Class C network. Actually, let me delete these scans. I said, scan the Class C network 10.10.0.0. Okay? All right. That's what I told them. And so many people had an issue with that. Because let me show you why. If I scan that, what's it telling me? There's one IP address and there's 0 hosts up. So many people, I won't mention Leroy's name, but no, there's a lot of people, they're like, it's down. How do you know it's down? Did you scan it? Well, 10.10.0.0 is what's called a network ID. It's kind of like, y'all should know where I live by now. Anyone know where I live?
Yeah.
Talk. 8412 Tree Line Drive. That's where I live. 8412 is my house number on Tree Line Drive. Hell, it's only on 8,000 videos. I even got pictures of me mowing the lawn. Anyone see the Google where I was out there weed eating? I'm out there weed eating around the mailbox, and there's a Google Maps card right there. It's like, whoa, that was kind of freaky. But they blurred out my face. It was crazy. But point is, so 8412 is my house number. Tree Line Drive is my street address. That's kind of like my network ID. So 10.10.0.0 is the network ID. It's not an IP address. So, let me go back to my current machine. Actually, I can do it on this one. Nothing is still up. Okay, y'all see that? See right here, we got a subnet mask in the middle there. 255.255.0.0. Now, you all should have taken Intro to Networks at one time or another. If you didn't, go up on my YouTube channel, search for CIT 1513, and watch Chapter 4 videos. There's like 3 of them. I think it's part 1, 2, and 3. Because Chapter 4, and I think it's Chapter 10 or 11, I go into really great detail about subnetting. But my subnet mask is 255.255.0.0. What that is it identifies what part of my address is the network and what part of my address is the host. Okay,
Class B?
that's a class B. Okay, that's a class B. If I told you, if you didn't know anything about me, where I lived or anything, if I just said go to 8412 Tree Line Drive, could you find that?
Yes.
Yes.
I mean, you didn't even know I'm from Oklahoma. I mean, say we're living in Puerto Rico, and I said 8412 Tree Line Drive. Believe it or not, the first thing on Google is Salt Lake City, Utah. I guess there's an 8412 Tree Line Drive there. The subnet is kind of like the zip code. Think of it like a zip code. It kind of narrows it down. Okay? All right. So this 255.255 is actually in decimal. That's my subnet mask. But the computers don't do a darn thing with decimal. They convert everything to binary. Okay? And 255, let me bring up Mr. Calculator here. Okay, there you go. I got Windows Calculator up. If I type in 255 in decimal, you can see I'm on decimal right there. Then if I hit binary, I get all ones. You'll see that. So 255.255.0.0 is 8 ones, 8 ones, then 8 zeros, and 8 zeros. Okay? In binary. Okay? The ones identify the network, the zeros identify the host. Now, he asked over there, is that a Class B network? Well, let me explain a little bit about Class B networks. Okay. Way back, okay, remember when computers first started coming out, and they came out with 64K of RAM? Okay.
Yeah, they don't remember.
Like the
I
4 hard drives?
No, we're talking the actual RAM inside of them. 640K is what they came with. I spent a couple $100 and upgraded to 1 meg.
Thought you were hot shit.
Then I upgraded to 2 megs. I actually had to buy a separate add-on card. I bought 9 SIP chips and actually had to put all these separate chips to get 1 more meg of memory. That was awesome. And then about a year later, oh my God, did technology change?
1 year.
I bought 16 megs of RAM for $600. Yeah, but back then, wow, 16 megs was like 85 terabytes. Now it was like unheard of.
And $600 was like $7,000.
Yes, exactly.
So,
So-
but still, 85 terabytes, you can't buy 85 terabytes for $7,000.
Yeah.
You can buy
But the point is,
8 terabytes of RAM?
but my point is, back then, I actually helped install the network in Tinker. I helped install the network in Building 3001, that super long building by Douglas. We helped install back then the ArcNet system, which ran coax, ThinNet. No more than 256 nodes on the network.
Help yourself.
We have pizza. Who wants pizza?
What?
Pizza, pizza.
Oh, I already did my piece. No. But, okay.
You put up with this guy?
And they just come here. This isn't even a class. They just show up.
I return fire.
Well, no wonder they show up. They can't cock-a-doodle-doo on that deal.
Yeah, but half
Holy
these
moly.
won't even eat pizza.
Wow.
Okay, so let me continue.
We get free class knowledge.
No, on a scale of 1 to 10, I hope you guys know this guy's a 270 right here.
Yeah,
That's
they-
all?
Especially
Oh my
since,
God.
especially since he every Friday he does lecturing here on the current project for forensics, and I'm like, good, I haven't started yet. Or
Yes.
every Thursday.
So
Good,
that's
I
what they
haven't
like
started
it
yet.
because
I'll
they're getting a
start
little head start on their projects. Okay.
You know what I like about, I'm probably silent, but you know what I like about this class almost as much as the pizza?
All right. So let me continue where we're at. We helped install that network, and the ArcNet system could only hold 256 nodes. That means no more than 256 computers. How long do you think that lasts?
Very, very short.
Not very long. Building 230, we installed ThickNet, that where each transceiver had to be at least 3 feet away from the next one. And that only holds 100 computers on a network. So obviously that lasted a long time. But back then, we figured that was plenty. Oh, hush. Okay. We figured that was plenty. Well, at the same time, that's when the internet was getting very popular. They broke the internet IP addresses down into A, B, C, D, and E networks. Okay, A networks were the very big networks. Give me an example of a big one. What do you think? Well,
A big network.
a big company. Who would have a big? Actually,
United
Hertz is one of the
States.
biggest.
Hertz?
Hertz. They're a worldwide company. They're everywhere. This is a few years ago. I mean, nowadays Google's probably the biggest, but
All hail the Lords.
back then. So Class A network is a very large network. Okay, a Class B network is kind of like a medium size. Those are our militaries. That's Tinker Air Force Base. That's Fort Sill. That's something like that.
3001 by itself.
Class C are the small networks. That's like your ISPs. Okay, stuff like that. So I'm going to, right here, I'm going to type NSLOOKUP. I have my own network at home. Deweyed up, mine not new. So the way the numbers worked, from 0 to like around 127 was an A, from 127 to, man, I can't remember now. What the heck? What was a B? Well, put it this way. I can't remember. It's been that long since I've done that. I don't have the Intro to Networks book with me. But okay.
128 to 191 is B.
There you go.
122 to 223 is C. 224 to 239 is D. 240 to 250.
Okay, so what's an A?
1 to 126.
So 1 to 127. That's my home network right there. What's my home address? So 68.12.188.19. So does that mean I have a very large network in my house? No, what that means is my provider, which is Cox, is a large network. Then they kind of divvy out the addresses. Way back when I worked for a couple different ISPs. Then I made my own. It was funny because I contacted Logix, and Logix was going to sell me a T1 line. That's a fast digital connection. 1.544 megabits up and down for $750 a month. Okay. Cox was going to sell it to me for $900 a month. So who do you go with? Cox, obviously. The reason is, believe it or not, Logix could not sell to a residential customer. Because there's something in the law that if I didn't pay my bill, they could not come into my residence and take the equipment back. Which is weird. And it turns out Logix charged you $5 per IP address. I need a couple hundred. So that's 750. All of a sudden, went way up there. Cox was 900. Unlimited IP address. You just justify to give you whatever you want. First they gave me 64, then I got 128. I kept increasing how many I got. But the funniest thing out of all was, I signed the contract with Cox, got it all ready. They went to install, like, oh, we can't install it at your house. They had Logix come out and install it. Because my line was actually a Logix line. Cox had Logix install the system that they couldn't sell me. Then Cox billed me. All the maintenance was done by Logix, 100%. But I just paid Cox. That was the weirdest thing. It's like, seriously? But, all right. So I have a very small network at home, but my provider is a large network. Okay. So here at Rose, our internal address on vSphere is 1010. So is that an A, B, or C? Just a 10 now. 10 should be an A. But a 10 network and it has like 16 million computers on your network. Do you think we need that much in vSphere? Probably not. A Class B network, which is what we actually have, right there, that 255.255. See, an A is 255.0.0.0. A way you figure out how many computers are on the network, it's pretty awesome. Let me go to scientific view here. Can you still see it? Okay. So 255, okay, is 8 ones. Did y'all remember that a minute ago? So if I went 2 to the 8th power, 256. How many zeros were there? So if there's 8 ones, how many zeros are there in binary? 8, but I mean within the Class A network. So if it's 255.0.0.0, 3 sets of zeros would be 24. So if I did 2, since we're talking binary, 2 to the 24th, 16 million computers. So a Class A network, there's only 256 of them in the entire world. But each one can have 16 million hosts on it. Okay? Class B, that's what we have here, 255.255. So there's 16 ones and 16 zeros. So if I did 2 to the 16th, I should have 64,000. 65,000. Okay?
But minus 2.
Yeah, minus 2, because, well, that's, I don't have time to get into all that.
Minus 2.
But,
It's simple. Minus 2.
minus 2, because you can't use the first and last, you can't use the network ID, you can't use the broadcast. But, so basically, on a Class B network in vSphere, is 65,000 enough? Could we get away with less, you think? Yeah. Could I get away with like 256 maybe? It'd be close. But I could up that a little. Maybe we could live with 1,000. Maybe 2048. But we have up to 52 schools using this system. And sometimes for a project, we'll tell someone, okay, you use 10.10.70 in that entire range for whatever project you want. That way it doesn't interfere with anything. And since it's internal anyway, it's not that big of an issue. It's why we have such a large network. Okay. So when I told my students do 10.10.00, that was really the network ID. What they needed to do is convert it to CIDR, CIDR, classless interdomain routing. And with that, you specify the network ID slash the number of ones. Okay? So if we look here, how many ones do we have here? 16. 8 for the first 255, 8 for the second 255. So we have 16 ones. So if I did 10.10.00 slash 16, I'll be scanning the whole entire Class B network. Do you agree? Okay. Now I told the students, scan the Class C network.
Scared me for a second. I was like, oh god, I did that entire time wrong.
Okay. But I told them to scan the Class C because why scan the whole thing? So if I tell you Class C, what's a Class C?
24.
So it's 255, 255, 2550. So it's 888, so it's 24. Okay. Feel better now?
Yes.
Okay.
I was like, I knew this 24.
So what that does, so looking at that number, 10.10.00 slash 24, what IP address is it going to scan? All in the Class C, but 10.10 what? It's actually, remember it's doing Class C, so it's only manipulating the last octet. It's only manipulating the last 0. So it's going to be 10.10.0.1 through 10.10.0.254. So this machine here was 10.10.40, wasn't it? 10.10.40. By running that scan, will I even look at this machine? No, because it's 10.10.40. When I said do the Class C, it was 10.10.0. So now, when I scan this, what it is that's our infrastructure machines. That's our servers, our vSpheres, our ESX machines. That way I knew you'd be scanning something with some open ports. See, there was a reason why I came up with that. Yes?
So I suppose doing 10.10.00-256.
Actually, you could do 10.10.00. Actually, you could do 10.10.01-256 and it would have worked fine. Maybe even 00-256 would work. There's a couple different ways you can do it. But I think on the assignment, I actually gave it to you with. Didn't I tell you with the slash 24 on there?
No,
I
you
didn't?
just told us Class C, and I swear like you bolded it or something.
Oh, so I want to make sure you knew that. Because if I look at your paper and you scan more, I mean, if you scan anything with a 1 in that third octet or a 2, that's wrong. So I didn't tell you to do those. Yes?
Does this work with IPv6 or only with IPv4?
I'm not. You know what? There's got to be an updated version, though. There's got to be.
It does V6.
Yeah, okay, I figured it would. I know it's IP4, but I'm assuming it would have to work with IPv6. Okay. And by the way, you can get a free IPv6 address if you want. Go to hurricaneelectric.com. It's free. Sign up for one. Pretty sure it's Hurricane Electric. It's something close to that. Horizon Electric, Hurricane Electric. HV? Oh, HE. Okay, there you go. HE.net. Same place. They're actually, yeah, there's something funny about that place, but okay. So you'll see that the host listed here. Now, if you look at the IP addresses of the host, what do you see? They're all in 10.10.0 something. See that? See that they're all 10.10.0.2 through 255 or 250. So that's the scan rate. What if I did the scan? Let's clear this scan out. What if I did 10, 10, 0, let's do a 30. See what we get with a 30. Should I get any? Should get. I think there's some in that range. Wait a minute, no, there's not. No, I think 10's the first. No, there is one. Okay. 2's on there. Okay. So 10, 10, 0, 0 slash 30, that means 31s. So how many zeros?
2.
Okay, there's 2. Because if we do in 31s, there's only 2 left because there's only 32 total. It's funny, when I got a job at my ISP, I teach this stuff all the time. I passed all the certifications in it, and they're like, we sell IP addresses in blocks of 8. What? Because everything's by 8. You realize that. Like 2 to the third is an 8, so on and so forth. I says, we can't sell blocks of 8. We can sell blocks of 6. Because you can't use the first and you can't use the last. Let me explain what that means again. Okay. The first IP address in any range is always the network ID, hence 10.10.0.0. That identifies the network. It's like tree line drive. The last IP address in the range is the broadcast. That way, if you remember, I think we picked up traffic the other day, all this traffic was going, we weren't doing anything. That was broadcast traffic. Okay, so the last IP address is broadcast, so you can't use those. Well, we used to sell 8 usable IP addresses. So as soon as I got hired there, I'm like, see what it was, a friend of mine ran the place. He sold it to his girlfriend and her new boyfriend. They were both idiots. And he took the money and ran. And they just, here, take care of the entire ISP. I'm like, oh, great. All they did was cash the checks. It was a bad deal. But so I said, we can't sell 8. Because we can't use the first and we can't use the last. So we can only sell 6. Nope, we're selling 8. I tried to explain it to him. He says, no. I said, you can only sell 6. Nope, we're selling 8. So sure enough, most customers didn't care. Because they don't know the difference. But I had one customer call me one day, goes, I got a problem. And he goes, I bought this network ID from you. I said, yeah. And he goes, I bought 8 addresses. I said, yeah. I know exactly where you're going. He goes, I only got 6. I'm like, imagine that. That's what I paid for 8. I said, well, I gave him 16. Because that's the only way I could do it. So I gave him 16, which means he could use 14, but only paid for 8. Because you can't use the first and you can't use the last. So when I did /30, that left me 2 zeros. So 2 to the 2 is 4. Can't use the first, can't use the last. So you end up with 2. Okay. So if you did 28, that would be 2 to the 4th. That would give us 16. Then you could use 14. Okay. So I should get a few more on this network. What you should do at your house, if you adjust your subnet mask at your house, like most of us probably have 255.255.255. That's what our routers come set to. I'm assuming we all have that. That's 256 addresses. Is that good or bad? First of all, do we need that many?
My house does.
Okay. I need quite a few on mine. I ran, did I ever show you guys Fing? Okay, well, there's an app you can get. It works on Android, works on iPhone. It's called, let me find it here, Fing, F-I-N-G. Totally free app. When you're connected to a Wi-Fi, hit scan. It shows you every device on your network. It's called F-I-N-G. You have to be on Wi-Fi to run it. It's actually pretty darn cool. I ran it when I was in Alaska at the Princess Lodge. I had 300 and some people in the network. No wonder it's slow. There's 300 people on your stupid wireless. But, so, if I was at my house and I had a Class C network, 255.255.255.0, that'd be 256 IP addresses, 254 usable. That's quite a few. I could actually make that smaller. And what that means is my network could actually be quicker. The smaller you make it, the faster your network would be. Like ARP and everything else doesn't have to check as many addresses. It doesn't have to resolve as much. So you can actually make it quicker by making it smaller. And it's more secure. That way people can't get on. There's not many addresses to give out. When you run out of addresses, you run out. But, mine's still at that because I have so many IP-enabled devices at my home right now. About freaked me out the day. I'm like, what is all these addresses? Well, it's my thermostats, my lights, my televisions, my everything's got an IP address now. So it's
I love the Internet of Things.
yes, it's just everything. Heck, my watch has an IP address now. found a neat feature on my watch. I can actually remotely control the camera, turn it on and off, and capture pictures with my watch. It's awesome.
No selfie stick needed.
What now?
No selfie stick needed.
Yeah, exactly. All right, so again, by putting on 28, I was actually scanning, so that's 4. So 2 to the 4th is 16. So I actually did 14 addresses, and it should have told me that somewhere at the beginning. Okay, did it tell me how many? Where's it telling me? Is it at the bottom? 16 IP addresses, 7 hosts up. But again, the network ID and the other one you can't use. So you see you got quite a few of them. Now, another way I could have done this, which I think someone mentioned, I could have done like 30. That should have scanned 1 through 30. I think that would work. Let's see if it works. So a very nice tool on the amount of stuff you can do with it. Yep, that would work as well. So you could do 10.10.00/30. That would do 00 through 30. Obviously 00 would be down, but then you could do the other ones as well. So there's lots of ways you can use this tool. And there's lots of other options, okay? And there's even more options beyond this. Like, I think -O will give you the operating system, or is it -A gives the operating system? Yes. Should be -O. Let's put O in here. So you can actually edit this. Is it dash big V, little v, isn't it? Just small BVs? Okay. So I can do that and scan that. Okay. Let me clear out some of these other ones, just so you can see only the results of the ones I'm doing. So you can edit the command right there. Still running? Okay, still going. Wow. What now? So it's more and more and more information. Look at all the information that's found there. So it is kind of cool what it can do. It's just going to take a while to run. But it's a free tool, and there's lots of information on it, so play with it. So would that have helped you if you had this first, Leroy? You know, I have a guy from Francis Tuttle Votech watching all these videos. I'm like, oh yeah, I watch every time you post a video. I'm like, seriously? Oh, wow, look at all this stuff. Yeah, I guess. He goes, you give them too much information. He actually came 4 o'clock today. He goes, you give them way too much information on their assignments. Yeah, see, y'all think I don't give you enough.
Because the assignments are
Most
hard.
Never
these
told
are
you
too
that.
late to help.
But look at all this information it got. Wow.
This was due for the pen testing.
I feel like it's out of the 4.
You should have asked the question.
I did. I called in more than once.
All right, so I think that's a general overview. Again, the command line version, this is the command. I mean, if you're unsure of the command, type it in here. Or heck, just go on.
I
Yeah.
tried to see nMap, but it
There's an awesome website right here. Let me show you. It's really cool.
I don't think
called-
in your teaching video you told us about the Microsoft document that has all that.
Oh, I didn't?
No, so I was Googling it and I didn't think that it might.
If you watch my intro to networks video, chapter 4, it's in there.
Well, we didn't know
That's good
that.
information to have.
Cause I used to install networks and configure networks all over. I was like awesome at it. And that's why I cover certain stuff in great depth. But if I go in here and type nMap, it's give you tons of it. Top 30 nMap commands. I mean, they'll tell you exactly what they are. You know, what computers on your network.
The most computer-oriented slash.
There they are.
I don't think the command was the hard part.
Give me into what you
All right. So, look at that. Turn on OS, version detection, scanning script, find out host. Wow, all this stuff. Okay. There it is, -6 for IPv6. That answers your question. All right.
I did find a good site that explained all the ports and the viruses.
Yeah, there's lots of good sites out there.
I think
And,
it's on the
It
website.
did
Test the
from 1 all the way to
viruses.
49,000 something.
Yeah. And don't think I'm asking you guys this stuff because I don't know. It's just I want you to figure it out. A lot of this stuff I know, believe it or not. I just want you to figure it out because sometimes I don't know. Very few and far, and I will never tell you.
What's the price of tea in China?
I could ask Siri, she'd tell me.
Like stale tea in China.
Okay. All right, so, kind of helpful. Anyone, questions on nMap?
Maybe last week.
Last week.
I'm gonna have to watch it later. I was running.
Can you detect a scan?
Yes, you can detect scans. Okay.
What?
It's actually the way, it's like I don't know if I told you guys when we did the Wireshark video last week. I told you don't install this at work.
Yeah.
The reason is like Wireshark puts your machine in what's called promiscuous mode. It makes the way a network card works is you got all these packets coming across the wire, and every one of them hits this machine on your, pretend you're on the same port of a switch, okay? They all hit my machine, but my machine only accepts packets destined for itself or broadcast, okay? You can actually scan a network and look for machines that accept all packets. In other words, you're looking for machines in promiscuous mode, okay? With nMap, yes, you can. There's IDSs out there that will detect nMap because the signature that it uses, like the SYN scan and all those other ones, what a SYN scan is, y'all know what a three-way handshake is? That's, Leroy, I want to talk to you, and you said, okay, I want to talk to you too. Okay, good, let's communicate. Well, it's a SYN, then an ACK, a SYN, then a synchronized, and an acknowledgement. A SYN scan sends out a bunch of SYNs. It doesn't, I send a SYN to Leroy, he sends me an ACK, and I don't respond. So there's a signature for that. So yeah, they can detect some of these scans based on that.
Is that what the no ping function was for?
No, what normally happens with nMap is it will ping the address to see if it's alive and if it's a good address for you. If you say no ping, it basically doesn't test it. It just assumes it's good. Because first of all, ping, believe it or not, is being blocked most places anyway. Here's a easy way to show you that ping's being blocked. If I'm over here and I type ping www.google.com, I'm going to put a -T after it so it doesn't quit. Okay. Now I'm going to bring it up again on this machine. Okay. Now I'm on my local machine here. Do I? But all right. So the command works. 'Cause I just did it up there. So why is it working up top but not on the bottom? Yeah, but what? No. But still, I did the same on both. I did the -T on both.
Do with the firewall.
Has to do with the firewall.
Can't receive it.
Our firewall is blocking ICMP, which is Internet Control Messaging Protocol, which is ping. And those of you who are doing the current pentest assignment, the second packet, I think, is actually a ping packet. So if you were to ping, it'll actually, that's how you, if you want to see exactly what that packet looks like. Did you find that out? The one with the alphabet in it?
Yes, I
Okay.
did. You
Okay.
did your every block.
Yeah, I got that. But it's actually a ping packet is what it is. Yes.
Why does it block the classroom computers?
Okay, they're actually blocking the entire network. This bottom one, the only thing that's not blocked is the CyberLab network. Because a few years ago, eBay and Yahoo were taken down by pings. If you read the book Spam Nation by Brian Krebs, he talks about spam, but he also talks about all these botnets. And I forget which botnet it was, but this botnet was getting really pissed at these companies. So within an hour, they got 25 million machines remotely to attack this place and took it offline instantly. So what happens is places like Rose State now block ping in and out. That way you couldn't be malicious to somebody else outside. Okay, I was actually teaching that class up in Colorado. It was funny because we were running nMap and we were running stuff like that. And I was teaching a class for instructors. So all my students were actually instructors in other schools. They all just came to Colorado. Well, what we did was I had them scan their own schools. So you'd run nMap against your own school. Okay? Then I get back here from teaching the class, and I got contact from IT services. Well, Lawton, that's universities down there, Cameron University in Lawton, had detected it. They detected the scan coming from Colorado that was actually happening through the vSphere network, contacted Oklahoma State Regions, who then contacted Rose State, who contacted me to see what the hell I was doing. Then here's how I responded. She says, yes, we were doing a class project. Each student was checking their own schools. Oh, and by the way, I scanned Rose State, and you didn't detect it. And they're like, oh. I had 16 instructors. One school even noticed it. I mean, I was scanning external ports. It's not like I was remotely breaking into something.
Yeah.
I was scanning external ports, but it was so funny because they're like, you did? I'm like, yeah. I told them, I said, there's 16 schools. I scanned Rose State, and Pedro scanned Cameron, and so scanned their school, but not a single school noticed it except for Cameron. I was impressed that they saw it. I'm like, wow. So we just did nMap and hydrated a couple other things on it, just basic stuff. So kind of interesting stuff. So, all right. So helpful, maybe.
Yes.
All right. I got a note down on my desk to make a presentation on salt for next week.
Okay.
If we like something else, please let me know.